Now, sorry, I'm just fixing this up. Now, any mention of max or min in a calculus question means that equal to zero. I know it does talk about retaining the volume and all that. So some of you kind of went off on a tangent with the volume, but it says the surface area is, and then you're asked to minimize the area. So all you had to do was differentiate once and let it equal to zero. Now, before I start, it is probably easier to rewrite this as, and same with the next one. It might be, well, it is better, especially because the or is underneath. You're going to write it like this with your pi and then your or to the power of -1. So you kind of need to have it in that format before you can go ahead to differentiate. So now I'm going to differentiate this dy dor because it's in terms of radius. So the 2 comes to the front, 5/3 pi or itself. Then the -1 comes to the front, so it becomes minus pi, and this becomes or to the power of -2. Now, we're supposed to then let this equal to 0. So before I do that, I'm just going to tidy it up to make it, again, I suppose, back into the format now again. So pop these over 1 if you find it difficult. So it's 2 and 5 and pi and or on top. So 10 all over 3. And over here, and it's going to be 3 or squared on bottom. Now, I'm going to let that maximizing, we differentiate once and let it equal to 0. So what I'll do is the or squared. Now, it has the 3 already, but it doesn't have the or cubed. This guy, now I cross multiply 10 pi or cubed minus 1250 pi equals, and that's going to be 0. So now I'm going to move this guy over. So I'm trying to find out basically the value of or that minimizes this. So he goes over there, or cubed. So I'm going to move the 10 pi over and they're going to divide. Now, when I do all of that, I end up getting or cubed is equal to 125. So or is 5. So that's basically my answer done, but I need to make sure that it is a minimum. So what I'm going to do is I'm going to go back and get my d2yd or squared. So I'm basically going to differentiate again. So that's why I'm going back to this line here. So the or comes in the front. So that ends up just being my 10, 3 pi, and the or is gone. So I'm using this line here. And then this becomes plus, the 2 comes to the front. So that becomes 2500 pi. And that's all over 3. Now it's all over 3 or squared. No, or cubed, sorry, because I've differentiated again. Sorry, I might just take that a bit slower there, actually. So that, just to explain, that becomes or to the -3. So I'll just fix it in the next line then. So I end up with 10 over 3 pi. This is 2500 pi, and it's all over or cubed. Now, that's my second derivative. But now I need to just fill in my value of or that I found. So I know that or is 5. So I'm doing 10 over 3 pi, or you can put the pi on top. It doesn't really matter there. So that becomes 2500 pi all over 3. No, did I drop out the 3? What did I do? Sorry. The 3 is still there. Sorry. So that's over 3. I knew I'd done something there. And then I differentiated the -3, so the 3 is still there. Yeah, sorry. So the 3 is still there. Now, the or cubed is 125. And I suppose, long story short, what ends up happening here when you put it into your calculator is that 10 pi is bigger than 0. Therefore, it is minimum. So we just do this bit really as a check to make sure that it is minimum value, which is what we were asked to do to find the minimum.